Binary choices, or choices in which there are two outcomes, yes or no, are an example of a situation in which we cannot assume that the data will follow a normal distribution. Instead, binary choices follow a Bernoulli distribution. There are two outcomes in a Bernoulli distribution, one meaning yes or 0 meaning no. P is the probability of a 1 or yes answer. Therefore, the probability of 0 or a no answer is 1 minus P. To calculate the mean of the Bernoulli distribution, we get the weighted sum of the two outcomes, 1 and 0, multiplied by their respective probabilities. To write out the likelihood of a single observation from the Bernoulli distribution, we use this formula. The equation is p raised to the power of y times 1 minus p raised to the power of 1 minus y. If we look at the outcomes of the two possible values for y, this makes sense. If y equals 1, p raised to 1 is p, and 1 minus p raised to 0 is 1. So if y equals 1, the likelihood is p. If y equals 0, p raised to 0 is 1, and 1 minus p raised to 1 is 1 minus p. So if y equals 0, the likelihood is 1 minus p. This is in accordance with the expected probabilities of the Bernoulli distribution. The next equation tells us again that the likelihood function is the product of the likelihoods associated with each observation. So how do we go about bringing marketing activity into all this? We already discussed the Bernoulli distribution and the likelihood function, and now we're going to adjust the likelihood equation to account for marketing activity. It's the same equation, but now the probability P is a function, P of X. The X represents the various marketing activities. The example that I'm going to demonstrate in the next video via Excel involves customer acquisition. We are going to look at if the probability of customer acquisition is affected by various factors, for example, sending them a coupon in the mail. The technique that we will use is called GLM, or a generalized linear model. The logit model is commonly used to represent binary data. The probability is an exponential function, e raised to the power of x transpose beta divided by 1 plus e raised to the power of x transpose beta. X transpose beta is actually our regression equation, intercept plus beta 1 times x1 plus beta 2 times x2, and so on. Basically, since the regression equation can take on positive or negative values, what the logit model does is it rescales our answer to be in the form of a probability, which, as we know, is a value between 0 and 1. In the next video, I will demonstrate using Excel how we can calculate some of the values of these beta coefficients.